Hello my dear students, let us see one very interesting sum in the topic indefinite integration in the module integration by substitution. What does the question look like? It says integral of 1 upon x raised to 1 by 3 plus x raised to 1 by 2 dx. Now my dear students, we have not encountered this problem earlier. You have two different radical signs. In the earlier sums we had only one radical sign. Now here there are two different radical signs, so the solution may not be following the same path as the earlier sums. Let us at least copy the question. So this is a question. Now what am I supposed to do in this sum? My dear students, you can mark this sum as important because it has a slightly different method. What do we observe in this case? We observe there are two different radical signs. So here I can term this as we have a mth root and a nth root. That is, we have some x function raised to 1 by m and x function raised to 1 by n. So what are we supposed to do? In this case, let us say m is 2 and n is 3. So in this case, what am I supposed to do? I am supposed to substitute x as t to the power LCM of m comma n. X will be t raised to some number and that number is LCM of m and n. In this case, m is 2 and n is 3. LCM of 2 and 3 is 6. So we'll have to substitute x as t raised to 6. So let us put that x as t raised to 6. Now this substitution is so convenient that it will remove both the radical signs. Okay, so let us proceed further. Let us differentiate. So can I say dx is 6t raised to 5 dt? Is that okay? Let us substitute and you will understand why did we substitute x as t raised to 6. So the integral will look like the numerator was dx. So it will become 6t raised to 5 dt. That will come later. And in the denominator we have x raised to half, which is t raised to 6 raised to half. And we had x raised to 1 by 3, which is t raised to 6 raised to 1 by 3. And now let me write 6t raised to 5 dt. Now my dear students, you very well know t raised to 6 raised to half becomes t cube. So let me write that 6 outside first because it is a constant and t raised to 5 in the numerator. Now let us write here t cube plus t square and dt has to follow. Now my dear students, in the denominator can we say t square is common. So we have t raised to 5 upon t square into t plus 1. Obviously t raised to 5 and t square can be simplified to get t cube in the numerator. Is that okay? So the integral says now t cube upon t plus 1 dt. Now ideally my students, if I talk about integration, this is integral of a function which is of the form p of x upon q of x, that is polynomial upon polynomial. And in this case, can I say degree of numerator is greater than degree of denominator? You can check here. Degree of numerator is greater than degree of denominator. So technically, I am supposed to perform actual division. Actual division means t cube will be treated as a dividend and t plus 1 will be used as a divisor. But my dear students, in this case, it is easier to solve by adding, subtracting 1. So what we'll do here is, we'll add, subtract 1 in the numerator. And you may wonder why so or how does it help? Let us see that also. Now, what I'll do here is copy this step for your understanding. Now, my dear students, if you consider t cube plus 1 together, it is of the form a cube plus b cube. So, if it is a cube plus b cube, we know the formula, that's a plus b. So, in this case, it will become t plus 1 into t square minus t plus 1. And obviously, that minus 1 has to follow upon t plus 1 dt. Now, my dear students, if I consider t plus 1 as a single unit, again I come to the same point that the denominator is a single term, so we will separate. So in the next step, can I write that 6 outside? And now we'll have t plus 1 into t square minus t plus 1 divided by t plus 1 minus 1 upon t plus 1 dt. Is that okay? Now my dear students, can I say that t plus 1 here cancels in the first integral? Very good. Now what we have is simple polynomial to integrate. Very nice. So we have 6 times integral of t square dt minus of t dt plus 1 dt minus of 1 upon t plus 1 dt. Is that okay? The first three integrals are of the form x raised to n, the last one is 1 upon x. So let us integrate, very easy for us. So it will give me 6 times integral of t square, that will give me t cube by 3 minus of t square by 2 plus t minus log mod of t plus 1 plus c. Now my dear students, we have to substitute the value of t. So let us write that is equal to 6. Can I keep that 6 there only? Now t cube, what is t cube equal to, or what is t equal to? Can I say it is x raised to 1 by 6? Because x was t raised to 6. So can I say t is x raised to 1 by 6? So what we will have here is x raised to 1 by 6, the whole raised to 3. Upon 3 will be there as it is. Likewise, minus of x raised to 1 by 6, the whole raised to 2. Upon 2 will be as it is. Plus of t only, so it will be x raised to 1 by 6 minus log mod of x raised to 1 by 6 plus 1 plus c. Is that okay, students? Now x raised to 1 by 6 raised to 3, so can I say x raised to 1 by 2? Likewise, x raised to 1 by 6 the whole raised to 2, can I say x raised to 1 by 3? And the remaining terms cannot be simplified further, so obviously this becomes our final answer. So this is a sum where we had two different radical signs. Let us take one example for homework on the same lines. So this is one question which you should try, and in this case you will substitute x plus 1 is equal to t raised to 6. That's all we have in this module. Thank you very much.